Okay, a little quick synopsis of variation. We find that in the my open math assignment I've composed on proportionality and variation, people have very little difficulty with the proportionality, but when you get to variation it can get a little confusing. So we have a variation problem where y varies directly with x and inversely with z squared, and y equals 12 when x equals 2 and z equals 3. Now, you don't need this information, and there's actually a question that follows it that's over there. Not even worrying about that question. Let's not even worry about this information. Let's just look at this part. Y varies directly with x and inversely with z squared. Okay, well, you know that if y varies directly with x, you get y equals kx, where k is an arbitrary constant that you've got to evaluate given some information about x and y. Okay, so that's y varies directly with x. Now you know that an inverse variation puts the variable in the denominator. Specifically, if y varies inversely with z squared, which is the case here, then that would give you y equals k over z squared. Well, we don't do either of these. We combine these two statements, these two characteristics, into one equation where y equals k times x over z squared, combining the kx with the k over z squared. Now we don't get a k squared, we're not multiplying these, but otherwise kind of looks like we were. But this encompasses the fact that y varies directly with x and inversely with z squared. Then we put our information in. Okay, y equals 12 when x equals 2 and z equals 3, so we put 12 in for y, 2 for x, 3 for z, and we get this. And then we just do the arithmetic of, well, we do the solution to this. If 12 equals k times 2 over 3 squared, then k is going to be 3 squared over 2 times 12, or 54. Now, if I've done the arithmetic right, and you always want to check my arithmetic because I do it all in my head, who knows where that is in a given day. There we have it, and now what do we do with that? Well, that's our value of k, so we plug that into our variation equation. Or we plug that into, yeah, this is a variation equation, we don't have k. We plug k in, and now we've got a variation equation we can actually use. So, if we're asked, for example, to find y if x equals 6 and z equals 12, we first write our variation equation, which I repeated from over here, same equation, and then we plug our values of x and z in, do the arithmetic, and we get our answer, 9/4 if you want a rational number answer, 2.25 if you want a decimal answer. So, just an illustration of variation, how it combines basic proportionalities, a direct and an inverse proportionality in this case.